I just want to say thank you for the invitation. I'm very happy to be presenting. I think, as I've mentioned earlier, I've been really impressed by the research that you guys have been doing, and I'm excited to continue my association and maybe, uh, as time permits, get more involved with the activities. Um, as I also mentioned, I'm here in the UK, so I happen to be 7 o'clock my time, so I'm working at home. Um, and I'm happy to present. And then I don't know if I'll be able to stay very much after for the workshop discussions, but I'm also very interested in that. My invitation was to discuss advancing simulation as a safety research tool. And just want to go over a few different things, really starting maybe with some discussion of my past experience to put my thoughts into context, and then present some ideas and challenges. And I think these match up well with a lot of your thoughts and plans for Safer Sim, and then share some ideas of possible approaches or solutions. Okay. So just my early past. So I actually got to work at the University of Iowa from 90 to 95. I was leading the development of the Iowa driving simulator. We were doing a lot of work led by Professor Ed Haug on virtual prototyping and a lot of the concepts of simulation-based design, looking at both vehicle development as well as human factors issues, looking at in-vehicle and road design. So this is a little picture of the Iowa driving simulator from back in those days, probably from 1993. So what research did we do? And I didn't get a chance to see Sue Chrysler's presentation, but I heard that a few years ago she had presented some stuff on the automated highway system research we had done with John Bloomfield. And so just starting kind of from the bottom up. So we did a lot of work looking at automated vehicles, platooning, uh, turning transition of control, both turning it over to the automated system and then taking back control and then exiting the platoon. One of the other areas that we did a lot of work on was various medical devices. We had a few different contacts with companies who were very interested in understanding the impact of the design of their systems on driving. And then at the same time, there were these various NHTSA projects going on trying to develop driver assistance systems. So both intersection collision, rear end collision, and single vehicle roadway departure. So a lot of work in that area. It was a lot of fun. The single vehicle roadway departure stuff, we had a chance to work with Carnegie Mellon and met a lot of the guys who were actually working on automated vehicles back then. They had done the hands-free driving across America at that time, so they were applying a lot of their automated vehicle research technology um, uh, to the issue of tracking when there's potential roadway departure. And so, again, a lot of interesting research looking at the different modes of warnings and kind of learning back then that there was definitely the visual channel in our research we found was kind of overloaded, and so haptic and possibly auditory were good options. Again, we were doing a lot of work also on the infrastructure side, looking at things like raised pavement markers. So trying to really stretch the capabilities of our driving sim. To do that research, we ended up building a static simulator, and we actually used that same static simulator separate from the Iowa driving simulator for the interocular implant work, so that we could put three projectors very close together to get a high enough resolution that we felt was good enough to test these systems. Okay, so after that, I went on in 1997 to found Realtime Technologies and got a lot of chances to work with a lot of different people across the country and several of you, which I've enjoyed immensely. We did some training simulators, but a lot of research simulators for a lot of automotive companies, a lot of universities, some racing companies, some flight simulation companies. So it's been a very interesting time through all of that. When kind of got towards the end of that, the automated vehicle deployment was starting, and there was a lot of research that went on, and a lot of simulators purchased from probably 2010 on to help in that development process. Uh, uh, really pushing again the state of the art with respect to uh, geospecific databases, software in a loop simulation, a lot of things like that. So, opportunity came up in 2015 for me to move over to the University of Leeds and lead the driving simulator there. Hamish Jamson, who is actually driving the car in this picture, was leaving to go work on getting a commercial pilot's license, and so I had an opportunity to replace him. And just so the group focuses a lot on human factors aspects of systems and designing systems, especially automated vehicles. So Oliver Karsten, Natasha Merritt, there's a lot of a really strong team here of researchers. So it's been a lot of fun. I've really enjoyed getting back to the university because I just feel like this area of simulation is moving so quickly that it's really important to try to stay on top of it if at all possible. Okay, so I think it's interesting back probably 10, 12 years ago, there are a lot of discussions, especially about whether results from simulators can be trusted versus naturalistic studies. A lot of comparison of results, especially with respect to cell phones. And I'm not trying to say that there's a good or bad answer. I think that there's a lot of good research that's been going on in both cases. But I think also just in general, it's good to take a pause and think about as you design an experiment. So we're really, a simulator is built to do testing in a laboratory. And so that's very valuable. And field research also is very valuable. But as you set up a laboratory test, you need to ask yourself, are you really designing an experiment that's going to capture the issue at hand? In this particular case, the question could be, were the demands on from the cell phone speaking requirements, were those demands at the right level? I think over time we've learned that light demands can lead to greater focus on driving task, lighter cognitive demands, and then as and possibly improved lane keeping and things like that. And then as the demands get higher, then things can tail off. In addition to that, you have to start thinking about an externally paced versus self-paced task. So there's a lot of things as you set up a simulation experiment to think about, and to think what what question you're trying to answer, and then also, once you do have that answer, how you interpret it and present your results. Okay, so just another kind of highlight on this side. Um, like it says on the slide, I always enjoy reading a paper that's well designed. So as I said, a simulator is a testing tool, and we need to make sure that the simulator we pick to do the research is good. We need to build up a very strong experimental design. When simulators is already a tough environment to get the right answers, and so we really need to make sure we lay out an experiment that's going to have as much discriminating power as possible to test the various hypotheses we have. We also need to look at do research and understand what are the best performance metrics. So do literature search and understand what are the best performance metrics. Simulators happen to churn out a lot of metrics, so it's very easy just to analyze them all. But that's definitely not the best thing to do. So, and I'm not saying that across the board this is what happens. I'm just trying to point out that these are the things to worry about as we want to get the most out of our experiments. One of the things that is also of note is we typically tightly control our traffic patterns that are experienced by the driver, and we do this because we want to minimize variability in the experiment from that perspective, and thereby increase the the um, the power of the experiment, essentially. That is something that we might have to start to look at changing as we move forward, and it's going to make it tough, and we'll have to address that in a number of ways. Okay. So I've presented before some of the challenges of the simulator design, but I think in the near term we have maybe not near term, but in the midterm we have some potential for improving the simulator design. So I wanted to present these issues so that both so people can understand or be reminded, and then also to look at some possible solutions. All right. So one of the tough things as we try to lay out a display for a driving simulator is trying to understand the right distance that the display should be away. One of the things that we find is that objects, if they're placed, if so, here's the camera for a simulation, and it's projecting, say, onto a screen. So this is really where the driver sits and is looking at a screen here, and this is what's called the view frustum. And any objects that are beyond the screen, when they're drawn onto the near clip plane, the screen itself, those objects are going to be drawn smaller and appear on the screen. If those objects are in front of the screen and get then projected back onto the screen, those objects will end up looking just big and far away rather than looking appropriate, especially for 2D visualizations. So one of the things that the best way to overcome that is to bring the screen in as close as possible, so that as many objects fall beyond the screen. Now, one of the nice things working at the University of Leeds, our driving simulator happens to have a 2-meter radius spherical dome, and I didn't pick it out. Hamish did, but it turns out to be a very, very nice distance for this. But you could want to bring the screen in closer. The issue is, as you bring screens in too close, you get eye strain from accommodation. And that eye strain is actually worse than just if you're working at a computer, because the virtual image is further away, so you have these multiple reflexes of accommodation and vergence, and then your expectation that actually adds additional eye strain. So the solution to that would be push the screen out, which it becomes a balancing act between these two things. Okay, so the second piece, and this is probably one that I harp on all the time, people who know me, is being able to support the vestibular ocular reflex for driving simulation. And the only way really to do that currently is by providing a motion base. And this can either be in pitch or yaw or all the degrees of freedom. But probably the two most important ones for simulator sickness is pitch and yaw, and I just want to go into that for a minute. But basically, the vestibular ocular reflex, what it does is as your head moves in the world, gets rotated either by yourself or by being in a vehicle, your eyes will automatically know to move the other direction, so that you can maintain a gaze on a specific point. And so this is something that you can easily test just by moving your head back and forth. And as I move my head back and forth, I can still keep my eyes focused on the screen. And that's really your vestibular ocular reflex supporting that. So the first case where this is a problem in a simulator without any motion is for pitch. So as you drive along in the real world, this reflex makes it so that the car is actually pitching around your eyes, and your eyes are able to look out at the horizon, and the car pitches down. And if you look at some racing games and things like that, they'll have the car pitch up and down and keep the horizon level to try to improve this effect. We can't do that if we have a vehicle cab, but if the vehicle cab is being drawn in the screen, then this can be done. If you don't have the real motion of the vehicle as it's pitching down to cause it to go around you, instead the horizon just looks like it's moving up and down. And one of the things that a lot of people complain about when they're in a simulator, as they look at it, they'll say, oh, there's a real problem here. The car is pitching too much. So that's a typical feedback that you'll get. The other one that's even worse is in yaw, because as you try to go around large 90-degree turns, the lack of yaw motion cues really makes it difficult. And what people complain about is steering or vehicle dynamics, but it's really the lack of yaw motion cues. And we've been looking at this more recently at the University of Leeds and developing some hypotheses. And it really comes down to something more, we feel like a dancer trying to do a spin or a pirouette or something, and not being able to put their eyes on a specific point in the world and understand how the vehicle is yawing underneath us. So that's one of the challenges there. And of course, we all try to minimize turns and intersections because of that. Okay, so that covers just a couple major issues I see in both the visual system and motion system, and get into in a little bit some of the solutions. at this point, I want to move on and talk maybe a little bit about the future of driving simulation. One of the interesting things that people have always wondered about is, okay, if automated vehicles come quickly, then nobody's going to drive anymore. Nobody's going to need driving simulators. We as human factors people are just um, getting rid of, getting. We're going to end up without a job if we do the research well, and the auto companies do a good job in developing and delivering the technology. I think it's becoming clear, watching some of Steve Schladover's presentations and other things, that there's a lot of different issues, and there's always going to be a lot of human driving coming up. Uh, Beyond that, though, if we do end up not having a job in simulation, then I'm looking forward to working in this transport area in the upper right. Um, but really, it is a interesting question of what will get deployed in the future, and that really will have an impact on what do simulators look like. So here's my thoughts on things, and how simulators will need to move. In my mind, simulators won't get totally out of the laboratory, but we need to use simulation and driving simulators to be able to evaluate future transportation systems that don't currently exist. And we need to be able to evaluate those in a robust way. And so I think this means, from a simulator technology point of view, being able to support distributed and what I call massively distributed simulations, be able to support real world databases that can't be contrived. So there's so many issues, and when you work with the AV manufacturers, they want just lots and lots of miles of real road, and they want it imported into the simulation, but they want to capture the real road and do it that way. And the reason is because no one understands exactly what's going to trip up an automated vehicle, and so they don't want to come up with just simple databases, or even our ideas of what a complex database is. The idea is we just want millions of miles of real world places, with the appropriate lighting, with the appropriate dips in the road, with the appropriate sight lines, so that we can really understand the different possible problems. We need to improve our traffic models, and I'll get into that a bit, because in our simulations we can't get enough humans, so we need to be able to model the traffic that you interact with. That traffic needs to be more complex, and because of that, we're going to have to come up with new experimental designs, because, as I said, we need to make our experiments probably move a little towards naturalistic driving, just in a simulator rather than in the real world. Okay, so just to delve into some of these things a little bit. I think most people agree that driving simulators are very good at A/B comparisons. So basically, you simulate a baseline condition in the simulator, you look at a new design or some other factor that's important to you, and then you compare those two systems in the simulator, and you can understand which one's better, and the impact of that design in kind of a general way. And it's very interesting because I've gotten to do a lot of microscopic simulation recently, and the same issues come up there, where really you you develop a model of a piece of a city, but that model really won't work without having real data to validate your model with and to tune your model with. And then once you have that baseline working in micro simulation, then you can make some changes to it and look at the impacts of, say, different traffic light timings or an extra lane or whatever you're interested in. So with driving simulators being able to do that, then how do we compare um, human drivers interacting with each other with human drivers interacting with automated vehicles? If you think about it, our current driving sims, those autonomous, I'll call autonomous scenario vehicles out there, are very close to maybe an automated vehicle, but they're not very close to a real human driver. And I think that's partly why we resort to very controlled interactions with those vehicles. So the only way we really can test that in a good A/B way is to have two human drivers interacting with each other and then compare one human driver with an automated vehicle. And again, it's the same thing with pedestrians. If we want to look at how a pedestrian interacts with an automated vehicle, we really need to be able to test how a pedestrian interacts with a traditional vehicle in the simulation environment. Okay, so one of the things I think that you guys have talked about quite a bit, and Joe Kearney was nice enough to come and visit us at Leeds and do some excellent presentations, is pedestrian simulation. And this is something that we're also working on at the University of Leeds. So at the upper right here is the current pedestrian simulator that's at our transport systems catapult, which is focused on taking university research and getting it quickly out into small and medium sized, especially businesses, but in businesses in general in the UK. So that we're working with them on developing some pedestrian capability. In the middle here is our current pedestrian simulator, a small HMD based system with a little walking area to allow so as you walk, then you move forward. So it's simple but nice. And then over on the upper left is a visualization. This is really the IF-STAR system, but basically we're going to be developing a 4 meter by 9 meter kind of cave-based system that you'll be able to walk around inside of. And with the long 9 meter side, we feel we'll be able to really research a lot of interactions between pedestrians and vehicles and hopefully help research and improve safety in this area. But as is clear from the presentations earlier today, this is something that you guys are also looking at a lot, and I think the multimodal aspect of it is very important. Okay, so another area I think talked about a bit is the real world databases and how important this is. So there's a lot of work going on, continuous improvement. These pictures are from way back in 2009, but there's been continuous improvement in the modeling tools to be able to rapidly convert, say, OpenStreetMap data or LiDAR data into worlds that can be visualized. Okay, so I'm going to go back in time again to 1993 in the original Iowa driving simulator state machine model. Jim Kramer and Joe Kearney, this is some of their work back then. And basically, if you look at micro simulations and a lot of the other the traffic simulation models used in driving simulators and in like AimSun or VisSim or all those, it's basically a linked list of vehicles on the road that's only looking at the vehicle in front of you. And the question, as it only supports looking ahead, is that really enough for our interactions? And for that, I guess I just let you think about a thought experiment. If you're sitting at the back end of a queue and there's a vehicle in front of you that you're following, and then in front of that is a truck, and that truck begins to change lanes into your lane, do you hit the brakes before that vehicle ever makes it into your lane, or do you hit the brakes only after the vehicle that's right in front of you starts to slow down? So these are the types of modeling limitations that exist currently in driving simulators and definitely in micro simulation that need to probably improve to be able to do the research there. And I see that there's a question on the treadmill, and that particular treadmill that the Transport Systems Catapult is using is, I believe, a company in the UK, and I'm not sure the name, so I can find that out for you and get back to you on that. Okay, so in general, I think we need geospecific databases. It's important for training. We need inexpensive motion bases that can address simulator sickness, especially pitch and yaw. We need new displays that have variable focus distance. We need better traffic models. We need distributed simulation, multimodal simulation, and we're going to have to come up with new methods of experimental design to bridge between the laboratory and field research. And we're probably going to have to run larger subjects just like they do in naturalistic driving. So just to look at some of these. So correlated databases. So as I mentioned, there's a lot of work already. Companies like Civil Maps and Cognata are trying to develop, and this is a picture down here from the Cognata website. They're trying to be able to scan real-world locations and import them into simulation. And in my mind, and what we're trying to do at Leeds really is be able to bring in something like OpenStreetMap and convert that. And so we're working with AimSun, we're working with Trian 3D. So AimSun is a micro simulation engine, and we're working very closely with them and the company to try to progress that software to make it work as our traffic simulation in our driving simulators, and also be able to flow that into something that's usable visually. And we're using Trian 3D from Trian Graphics, and again, that's a software package that I've used a lot, working with Nissan and other companies, really generating hundreds of miles of visual databases using that. The question, of course, is if we have to go out and scan all that information using a car, there's a lot of challenges in that. First, you have to go out and drive it all yourself or have other people do it. Second, if there's vehicles in the way, you run into a lot of problems. So it's important, I think, to be able to get and take data from these various HD sources, these sources, again, used for automated vehicle development. So OpenStreetMap is one route, but the other route that's available is things like Here HD, and some of the other companies that are doing things like that. Okay, so this is another fun one. So this is a researcher, Jack Billington, who's at the University of Leeds, and I'll just leave the quote up there. So basically, they've been able to stimulate the vestibular system to provide proper rotational cues to offset the rolling of your eyes, so that you can get a proper, or what they say, a natural head rotation in the roll axis. So congruent visual and vestibular cues. So this is kind of at the edge of possible. And I know I've seen a lot of videos from 10, 15 years ago of people trying to do this at trade shows, and especially in Asia, and watching as they make people fall down. Um, so this is interesting stuff, and I think I'm hoping that this is where we're going to be able to go from a virtual reality perspective. The second area, and maybe some of you are familiar with this from HoloLens or these various systems out there, they're basically trying for the augmented reality to introduce programmable micro lenses. And so there's a lens, a flat lens that first um, makes the scene look a particular distance away, which is like a typical HMD. And then on top of the base lens, which is here, on top of the base lens, they have a second set of lenses called a microlens array. And what you can think about this, as you render your scene onto the HMD, then you then take the Z buffer information from that, and you use it to program your micro lens array so that you can then make the various objects look to be the right distance away. And so this is another very promising technology that I think you're going to see first implementations shortly. I think there's already some on some of the GoFundMe type sites, Kickstarter sites. I haven't seen a fully working system yet, and obviously there's a lot of big players out there working on this. But this is another important advancement for HMDs. Then the last piece I guess I'd like to talk about a bit is this whole idea of the traffic simulation. And what I'd like to think about is that if we can develop really good automated vehicle controllers that drive like a safe human, could we then just take that controller and put it into our traffic micro simulation, so that then at least we'd be driving and interacting with vehicles. They'd be a lot more realistic than what we currently have in micro simulation. Of course, they wouldn't have the variability of real human drivers, but they'd be a step in the right direction. And I think one of the things that when the company that bought Realtime Technologies, FAC Incorporated, some of you might not know, that they actually do all the Top Gun ranges from, if you've seen the movie Top Gun, so they would be able to predict all the missile flyouts and everything like that. And those models got to be so good of the Top Gun ranges that they ended up taking those models and using them in the actual military aircraft to understand what the aircraft they're interacting with, what its capabilities are, as well as what the weapons on board your aircraft are, to understand whether those systems are, whether you should fire a missile or not, basically, whether you have a chance of hitting that other vehicle. And I'm not a big military guy, but I think similar types of ideas and technologies can really help as we try to make micro simulation of traffic work well, and also then improve our automated vehicles, because it can be a really dynamic interaction between these two developments. If people are constantly getting to interact with these automated vehicles in the simulation world, we can have them improve in their interactions. Okay, and then one last area I want to talk a bit about is scenario design. And basically, trying to formalize the scenario process. So there's been over the years various attempts at formalizing scenario development for driving simulation, and people more recently have turned to the scenario development for automated vehicles and tried to leverage some of that for driving simulation. So here, what on the far left is maybe the simplest, what they call open loop test, and basically we have a scene. So this is like the virtual world we're driving in. We give the driver a certain set of goals and values. So they need to drive here, and they need to get there in 20 minutes. And whatever other trade-offs there are. And those things combined produce a situation, and that situation is fed into the driver, and the driver then performs some kind of action. And in this case, an action is a little higher level than just continuous control. It's things like changing lanes or making a turn at an intersection, maybe stopping for an intersection, those types of things. That action and any additional external events then feed together onto the scene, and we move downstream in what they call closed loop testing. So you basically have this scenario that evolves over time because these new situations keep developing based on events and based on the driver's action or the automated vehicle's action. So these types of concepts have been extended now to the distributed simulation. And so again, it's the same type of thing, and you can build kind of a graph of the possible outcomes. So here you can see the driver, vehicle A interacting with vehicle B and C, and at some point, and that might reflect a certain point in time and sequences, and then the vehicle A changes lanes and passes vehicle C, and so that's represented by a different point in the scenes. And the edges in between are basically actions or events that occurred that caused that to happen. So the vehicle changed lanes, and then they passed vehicle C, and we got to this point. And so the concept within a distributed scenario design is the idea that obviously you're going to have a system like this for driver A, and you'll have a whole nother situation going on for, say, driver C over here. And the question is, you want driver A and driver C to intersect at some intersection. So you want them to end up at this possible scene here. And so then the question is, what additional events can you introduce into the system so that you encourage driver A and driver D to end up at their proper point in the scene here and interact? And there's a variety of things that have been suggested in the literature, but this is probably something that needs to evolve and advance more. And just a whole bunch of research needs to be done to understand how best to have these interactive distributed scenarios. All right, so that's my 45 minutes, and at this point, hopefully that was worthwhile to you, and I'm happy to take questions. I saw that someone is looking for a copy of the presentation. I'm happy to get that out and share it with you.
Yeah, thank you, Rich. And if you send me the presentation, which I think you already have, I can actually send that out to all the registrants of everyone that registered for if we would like to send it out to the whole group. Um, you send me.
Okay, that sounds great. I will send it to you for sure.
Yep, and as Dawn mentioned too, we're gonna be posting a recording of the basically every presentation today on the Safer Sim YouTube channel too. So we'll have your insight and everything there as well. So we have a couple people typing.
Sounds
We'll see what comes in.
okay. Okay, sounds good.
Okay, so I'm going to address the top one first from Don Marshall. So earlier today, a question about accommodation came up for one of the new projects. Do you have any references or authors you find particularly helpful? Particularly helpful.
I can definitely dig up a few things on that. It's a subtle thing when it comes to measuring it in the lab. Um, but there's definitely a set of research, and I'm happy to pull together some references on that and share it with you.
Excellent, thank you. We have a question from the Hank Lab here at Iowa. Great talk. How important is it to capture the motions, gaze, gestures of drivers in the vehicles for driver to driver and driver to pedestrian interactions?
Thanks. That's an excellent question, and it's not something that we've been able to answer directly yet with any of our research. Um, we have a big European project called Interact, which is funded under Horizon 2020, and we're looking at these types of issues. I don't know, to be honest, I'm not the right person for what field research has been done and captured. I know we haven't done anything in the driving simulator yet. What my goal is that we will provide the gaze and gesture information between the drivers of the vehicles and the driver to ped interaction. So for our pedestrian simulator, we'll be tracking that information and then having uh, an avatar being presented properly for the drivers to interact with. And from a driver perspective, I think I mentioned that we're thinking about actually using just a webcam and being able to film the actual driver and present that driver back to the pedestrian. And we'll see. Um, I think that we'll get through all our approval process here. At that point, once we have information going back and forth, one of the studies that I want to do is looking at how we can degrade that information that is exchanged, and maybe by reducing the amount of information flowing back and forth, we can start to understand exactly what AV needs to communicate um, with the pedestrian. I know there's a fair amount of research out there already that show the vehicle placement on the road and how the vehicle slows down are important cues for the pedestrian. But beyond that, I don't have enough information, but I'm really excited about doing more research on that.
Okay, well, let me just reiterate what people have been commenting here in the chat box, but thank you for the excellent presentation, Dr. Romano. Your insight is very valuable to this whole group, and we definitely appreciate it. and appreciate your involvement on the SaferSim board as well.